Somewhere right now, code is being written and no one's hands are on the keyboard. Not autocomplete, not a suggestion you approve with a tab key. Actual code, planned, written, tested, and corrected by something that isn't a person. 42% of all code committed today has AI involvement in it. That number was in single digits 3 years ago. And the shift that got us here didn't happen with an announcement or a headline. It happened quietly, one tool at a time, until the job of a software engineer looked almost nothing like it did in 2022. This isn't a story about robots taking over, it's a story about a profession being rebuilt in real time, and most people inside it haven't fully clocked how far it's already gone. So let's actually track it. From the first line of suggested code to full agents that write, run, and fix software with almost no human in the loop. Chapter 1. IDE Extensions versus AI Native Editors. It started small. GitHub Copilot launched as an extension, something you bolted onto the editor you already used. You'd type, it would guess the next line, and you'd hit tab or you wouldn't. The developer stayed firmly in control. It was assistance, not authorship. That model worked for a while because it respected the existing workflow. It didn't ask anyone to change how they worked, it just made the typing faster. Then the editors themselves changed. Cursor didn't ask to be installed inside your workflow, it replaced the workflow. Same with Windsurf. These aren't extensions bolted onto an old tool. They're code editors built from the ground up with AI as the default collaborator, not an add-on. And that changes the unit of work entirely. Instead of suggesting the next line, these tools can read an entire codebase, understand how files relate to each other, and edit several of them at once in a single coherent pass. That's the real dividing line. An extension adds a feature to your process. A native AI editor becomes the process. And once a tool can reason across your whole project, instead of just the cursor position, the developer's job quietly shifts, from writing every line to reviewing and directing what gets written. That shift alone would have been a big story on its own, but it turned out to be just the opening chapter. Chapter 2. Autonomous Terminal Agents. The bigger jump didn't happen inside the editor at all. It happened in the terminal, the place developers use to actually run and execute code. Claude Code doesn't wait for you to accept a suggestion. You give it a goal, and it plans the steps, writes the code, runs it, reads the errors, and fixes them, on its own, in a loop, until the task is done or it hits a wall it can't solve. That loop, plan, execute, test, fix, repeat, is the actual engine behind what people are now calling agentic coding. Devin took that idea and pushed it further, framing itself as an autonomous software engineer rather than a coding assistant. You hand it something close to a ticket, a bug report, a feature request, and it sets up its own environment, writes the code, tests it, and opens a pull request for a human to review. Work that used to take a junior developer 2 or 3 days now gets attempted in a matter of hours, with a person stepping in only at the review stage. What connects Copilot's successors to Devin and Claude Code isn't the interface, it's autonomy. These systems aren't just completing your thought anymore. They're executing an entire task independently, checking their own work along the way. That's a fundamentally different relationship between a developer and their tools. And naturally, that level of autonomy raises a very different set of questions, starting with where all of this code and all of this data is actually going. Chapter 3. Enterprise and Privacy Realities. Handing a tool your entire codebase means handing it your logic, your architecture, sometimes your credentials. And for a lot of companies, that's where the enthusiasm hits a wall. When code runs through a cloud API, it leaves the building. It touches someone else's servers. Even with enterprise agreements and no training clauses, that's a trust decision, not just a technical one. And plenty of legal and security teams aren't ready to make it for their most sensitive repositories. That's exactly why local-first tools exist. Ollama lets developers run open-source models entirely on their own machine. No API call, no data leaving the network. Klein can operate against those local models inside the editor, giving you the same agentic, file-editing behavior, but fully contained. Nothing sent out, nothing logged elsewhere. The trade-off is real. Local models are typically smaller and less capable than the frontier cloud models, but for regulated industries, defense contractors, or anyone under strict compliance rules, that trade-off is the price of keeping control. So the AI coding landscape isn't really one story, it's two. Startups and individual developers are racing toward maximum capability, plugging into the most powerful cloud models available. Enterprises, healthcare, finance, government, they're often moving deliberately slower, favoring control and auditability over raw power. Both are legitimate strategies. Neither is going away, which brings up the part almost nobody puts in the highlight reel: what happens after the code gets written. Chapter 4. The Developer Reality Check. Here's the number that tells the real story of 2026. 71% of developers say AI genuinely helps them solve complex problems faster. And in the same breath, the overwhelming majority say they still read the code line by line before it ships, not because the tools are useless, because they're good enough to be dangerous. AI-written code can look completely correct, compile without errors, pass a casual glance, and still contain a logic flaw that only shows up under a very specific condition nobody thought to test. That gap between looks right and is right is exactly why review didn't disappear. It became more important, not less. That reality is already reshaping what an entry-level job even looks like. The repetitive, boilerplate work junior developers use to cut their teeth on, that's precisely the work AI does fastest and cheapest. So those roles are shrinking, not gone, but smaller. And the pathway into the profession is genuinely different than it was 5 years ago. Meanwhile, senior engineers haven't become less necessary. They've become the checkpoint. Their value isn't in typing code anymore. It's in knowing what correct actually looks like and catching it when the AI is confidently wrong. Which points to the one skill that's actually appreciating in value right now. Judgment. Not syntax memorization, not typing speed. The ability to define a problem precisely, anticipate edge cases, and evaluate whether a system's output is genuinely sound. The engineers thriving in this environment aren't the ones refusing to use AI, and they're not the ones blindly trusting it either. They're the ones who've learned to manage it, treating it like a fast, capable, occasionally overconfident collaborator that always needs a second opinion. So the honest way to frame 2026 isn't AI is replacing engineers. It's that the job has quietly split in two. Writing code is becoming cheap and fast. Knowing whether that code should exist, whether it's actually correct, and what it will cost you 6 months from now, that's becoming the entire job. The tools will keep getting better. That part isn't in question. What's still very much in question is which skills stay valuable once the writing itself stops being the bottleneck. So here's the question worth sitting with. If AI can write the code, what exactly is left for the engineer to own? Drop your answer in the comments. And if you're building software right now, I'd genuinely like to know which of these tools has already changed how you work. If this breakdown helped you see the shift more clearly, subscribe, because this transition is still in its early innings, and it's moving fast.